Hi guys, how are you? I hope all you are doing good. Welcome to the Learn Code Easily. In this playlist we are moving further, and today we will do increasing order search 3. And yesterday we have done, I think we have done one question, I think, yeah, by parity something we have done. Okay, so today we will do this question. So yesterday we have done sort array by parity. So today we will do increasing order search tree, and it is a easy level, so we are not going to waste much more time. So let's move further, and it's my request to all that who are seeing this video, please like, subscribe and comment. And it's my humble request, if you are feeling that this is something good which needs to everyone, which need to know everyone, then please share this playlist with everyone and please subscribe my channel. So let's begin. In this question it is given that given the root of a binary tree, and we have to arrange the tree in order so that the leftmost node in the tree is the root of the tree, and every node has no left child. So you can see that this is a left, this now this is become head. Now we will take 2, now we will go for 3 for right, so there is no right, so we will take 3, then go for 4, then we will take 5, then go for 6, then we will go for this, then we will again see for left, so 7, then 8, then 9. So we have to arrange, and we have to arrange everything in the right, there is no left. So what we will do, let's make a function like bst, increasing bst, but I have make just bst, and this is our root. Okay, so I'm just calling this root our function, and I'm making a 2 variable. First is the because every time I have to make a node, so for that I am taking 2 variable, node, and second is I can say it result node, because after making this I have to result this node, so that it could traverse from here to here, because I have to return only the pointer which is pointing to here. So for that I have maintain a result node. Okay, so if root, so we have to call this bst every time, and first we have to call the left. Now you can see that when I will call left, so it will go, then it will go, then it will come to 1. When it will come, then it will see that there is no left of it, so we have to make that 1 as our new node. So we have to call for left. If root is equals to none, then we have to just return, and we have to call this again and again. Now what we will do, if we will say if node is equals to none, if it is true, then make a new node by tree node. So here I am making a new node by what? Root by val, and this is our first node. So, and this is our result node which we have to send. So I will store that node in a result node. If it is not the case, then okay, if it is not the case, then we will again make a new node, and then take node 1 dot write, I think node 1 dot write is equals to result node. This is our node, and if we will come here, so we have already initialized a node. So what we will we will just make a new node. We will make a new node. We have made a new node of this, but we have to point the previous node to the right of it. Okay, so I have made a new node. So the previous node is node So the node of right is what? Node 1. And now this is a node, so node of right, this is 2. And what is 2? I have made this, so this is pointing to the right of it. So first I was node 1 is here, now I have to point the node 1 is, I have to take that node 1 to 2. So for that, node 1 is equals to node is equals to node 1, and I have to return this bst root. Return what? Return, I have to return result of root. So every time, okay, so after this I have to call for the right of it also. So let's see that it is working or not, or it is giving me the error. If errors, and what is the error? So every time we are calling for the left, and okay, so no binding for non-local node. Okay, so no problem. So this is the node and this is the result node. So these are the two things. This is a node, this is a result node, and we have to initialize it as well, but I haven't initialized. So it has been accepted, it has been run. Let's submit it. So it has been submitted and it is 32 milliseconds, means it is much efficient. So what I have done here, I have just calling the left, we are making the new node, and we are just pointing, we are just moving every node to the right of the new node. Like we have made the 1, now we are now the new node which I have made just now, means I have made 2, but we have pointed a previous pointer to 1, and that is a node, and node 1 of right means the right of it is 2, and here we have made the new node which is node 1, so this is 2. Now the previous pointer is node 1 is pointing here, now I have to take that pointer to the 2, so that's why I have to initialize node 1 with node 1. Now it is pointing to here. Now it will again go and it will again check that the node 1 is also initialized. Yes, it is initialized, so it will come here and it will make a new node, means it will go there and make a new node, and the same process will go. Now our node is here, now we have to point node of right is equals to node 1. Now it is pointing to this, but the previous pointer is here which is node. Now I have to move that node to here, that's why I have to follow this step. And after traversing everything to here, I have to come to the right of it, that's why I have come here right. But when I come here, when I was reached there, so for that so I have to return this root as well. So for that I have maintained a new variable and stored that thing in a result node, and we have just returned it. So I hope you have understood, guys. I will meet in the next video, and it's my humble request to all who are seeing this video, please like, subscribe and comment, and please share this playlist with all who are needy. And it's my humble request to all, please share and subscribe, and don't forget to subscribe. Bye bye guys, I will meet in the next video. Bye bye guys.